Now this video is going to look at all of these transformations combined together. So let's look at a few examples to determine what's happening with our given function. So if we know the parent function f of x equals the square root of x, then we want to be able to graph the function h of x, which is negative square root of x plus 3. So once again, we know the parent function here is the square root of x, so I'm just going to draw this in. There's the square root of x. And now we want to go through the steps here. And I'm going to start with the inside. Now, we know that we have a plus 3 here, and we see a negative out front. Now, we know the inside of the function of plus 3, that's going to move the graph left or right. That's a horizontal shift. The negative out front is going to cause a reflection, and because it's in front of the whole function, it's going to be a reflection in the x-axis because we're changing the signs of our y values. Now, the order that we perform this does make a difference. Now, the way that I usually start with this is I think about how would you solve the problem with your order of operations. Well, if we had a value of x, the first thing is we would take x and we add 3. So the first thing I want to look at is what effect does the plus 3 have? So if we start kind of from the inside and work our way out, the plus 3, that says we're going to move the graph 3 units to the left. Remember on the inside here, this is going to be the opposite here, so it's going to be 3 units to the left. So that's going to give us this here. But then we have the negative sign out front, which causes the reflection in the x-axis. So then your graph's going to be reflected down. So this would be your final answer. So the only part of the graph we really need to see here is the green part where this is being moved over 3 and then reflected down in the x-axis. All right, the next example is going to really indicate why it's important to understand the different transformations. So if we have h of x is equal to a negative x plus 1 cubed plus 4. Now we know that the parent function, okay, because this is cubed, our parent function is the x cubed. So what we're looking at here is our kind of starting point is we're looking at f of x equals x cubed. And I'm just going to try to roughly graph this in. It's going to look something like this. That's our x cubed graph. Now we want to go through each of the transformations here. Now again, myself personally, I like to start on the inside and kind of work my way out. Otherwise you could possibly make a mistake. So I'm going to start on the inside. So what effect does the plus 1 have? Well, remember that's the inside. That's going to move the graph 1 place to the left. So if I move this over 1 to the left, we now have this graph. And then our next step is to take care of the negative sign, which is going to cause a reflection in the graph. So it's going to be reflected in the x-axis. So instead of now going from the left up, it's going to start here and go down something like this. Okay. And then all we have left is the plus 4, which is going to move the graph up 4 units. So we're going to go up 1, 2, 3, 4. So we're going to take this point and go straight up 4 units. And then we would have our graph like this. So that's going to be your answer, the purple graph here. So again, we went horizontal, reflection, vertical. And I think that's really the best order to go. Now, sometimes if you look in your book, you could always perform the reflection first. But here, the way this is set up, I always like to kind of start with the equation and go from the inside out, just thinking about your order of operations. All right, our next example, we have f of x equals the absolute value of x plus 4 minus 8. So if we want to sketch this graph, now of course you can always use your calculator, but we want to have an idea of what this looks like without the calculator so that we can make some kind of prediction of what the graph should look like. And once again, if we start on the inside and work out, we're talking about the absolute value. So again, our parent function is the absolute value of x, which is going to have our nice V shape. So if we start on the inside, we have this plus 4, and that's going to move the graph 4 units to the left. Okay. And again, if it helps you, I mentally think of taking this and setting it equal to 0, and we would get x equals -4. So we know we're going 4 units to the left. And I'll just kind of draw this in. So there's our graph. And then we're going to -8. So that means we're going to go down 8. So we're going to move straight down 8 units. And then we have our graph here. So again, 4 units to the left and then down 8. All right, now what I want to look at is if I give you the graph, I want to see if you can come up with the equation. So if I give you the following graph, let's say that we go here, this is at -2, and then we're going to go down 3. So if we're over at this point, left 2 and then down 3, and my graph looks something like this here. Can you come up with the equation for this graph? Well, first of all, we need to identify what is the parent function. Well, the parent function is, hopefully you can identify, is going to be the square root of x. Well, we know the square root of x is going to start here at the origin. So we need to figure out what transformations have we gone through to get this graph. Well, obviously we have moved to the left 2 units. So if we want to represent that, then remember horizontal is going to be inside the function. So if we're going here 2 units to the left, then that means on the inside that must be x plus 2. And then we're going down 3 units. So then it's on the outside of the function. So then we would have a -3 on the outside. Okay, so that would be the graph of this particular function. Again, x plus 2, 2 units to the left, -3 down, and there we have the graph of our equation. All right, let's look at another example. Let's say that I give you the following graph. Let's say that we have over 1, and let's say that we go up 3, and our graph is opening like this. So the first thing, again, you want to identify, when you come up with the equation, we want to first identify the parent function, which hopefully we can tell this is simply y equals x squared, and we know that our graph normally is going to start here at the origin and open up. So now, we know that the graph is moved over. We also know that it's moved up. Okay, so we can tell that we've gone to the left, we've moved up, but now it's also opening in a downward direction. So that means we must have had some type of a reflection at some point. So in order for this graph to go down, we must have a reflection in the x-axis. So we know that if we have y equals, we know we're going to have something here squared. And if we look, we shifted 1 unit to the left. Okay, so that means we would actually subtract 1 or add 1. Well, remember, this is going to be the opposite, so this is actually going to be +1, because if you -1 plus 1 gives us 0, which would give us this point. So the +1 is going to move our graph here. Okay, now we need to cause the reflection. Well, the reflection, we need this graph to now open down. Well, in order for us to have a reflection here, we need to change our signs. So therefore, we have to put a negative out front, and that's going to cause the graph to open downward. So now we have the right direction. We're over 1. So now all we have to do is go up 3 units. So in order to go up 3 units, we have to add 3 on the outside of the function. So here the equation would be a negative x plus 1 squared plus 3. That would give you the graph of this equation here. That would give you the graph here, the equation of the graph represented. All right, the next is going to be a little bit of a challenge, and I want to see if you can figure this one out. Let's say that I give you this point here. Well, let's move it to the other side. Let's go this point here, and our function looks something like this. And this point is located, let's say it's over 3 and up 2. All right, well, the parent function, hopefully we identified as x cubed, which we know that, keep in mind, x cubed looks like this here. So the x cubed function is going to go like this. So we need to figure out how are we going to get this translated to over here. Well, the first step is we know that we need to move over 3 units. Well, if we need to go over 3 units, then that means we're going to end up with x minus 3 cubed. So the 3 in here, minus 3, is going to move this over 3 units. And our graph would still have this same curve. But now we know that it's going to change direction. So we need to change the direction of the curve. So that means there's a reflection. And if we have a reflection here, that means if we put a negative in front of this, again, that's going to give us this reflection of the graph here. And then all we have left to do is to move the graph up a total of 2 units. So if we want to move this graph then up here to get this, we would have to add 3. So this would be the equation for the given graph. Again, we went over 3, then you would have the reflection, and then we would move, we would move not up 3, we would move up 2 units. And that would give us the equation for this graph. So hopefully now you have a little bit of understanding of how to go through all of these transformations. Just keep in mind that a lot of times you're best starting from the inside and working your way out as you perform the different transformations.